So what kind of wireless infrastructure do you think is needed to support that?
So what we need for this, obviously, is a combination of both. We need car-to-car communication or vehicle-to-vehicle communication, because cars will be en route in areas where the cellular system is not working. And we need a cellular infrastructure. And when we have both, we also have a certain resilience built into the system, because we can sort of do a majority voting or whatever you want to do. Yes, so when one system fails, we have a backup of the other, because we always have to get these systems into some kind of a fail-safe mode, such that if one level of communication is starting to break down, we have an alternative route. If another one breaks down, we know exactly what to do and give the control back to the driver so that they then take over the car.
Right. And do you foresee current cellular infrastructure, but with new radios and new base stations supporting this, or do you foresee much, much more dense infrastructure?
So we need a much denser infrastructure. We need, so that, I mean, 4G cannot do that, because I mean the reaction times in 4G are 25 milliseconds round trip over the air, so there's no way we can do it with 4G. So we need a 5G radio that allows for these shorter packets and shorter reaction times. A 4G packet alone is 1 millisecond. So by the time you actually collect the bits, transmit them, and decode them, you have 5 milliseconds wasted already right there. So there's no way 4G can do it. So we need a 5G system. But with this 5G system that we're going to have, we're going to see also the necessity to move the cloud computer controlling this to the edge, as we call it, yes, to the mobile edge. So right there into the base stations, also put the control servers, because obviously fiber optic cables are pretty slow. 200 kilometers per millisecond is the speed of light. That's not very fast. So if you were to have a car controlled in Austin by a cloud server in Alaska, you're really asking for trouble, because that's more than 100 milliseconds right there on the fiber optic cable. So it's not going to work. And that's interesting to see that we're going to have sort of all kinds of different things. And then, if I'm going along, what kind of an interstate? Obviously, I will probably have cases where the car-to-car is just enough. Then I will have my cellular system control it. But then the control server itself has to move as well. Yes, so you have to boot the application in the neighboring base station and its server. Then it has to get exactly the right state, and then has to be able to synchronize and then take over the car. So it is way more of a challenge than in 4G. In 4G, it's simple. We have a connection, we just hand off the connection. Here it is multiple connections, because one is not going to be good enough for making it reliable, and we have to hand off the application.
Which spectrum bands are you working in?
Which frequency bands? So I personally am working in the 200 gigahertz band, so millimeter wave band at very high frequencies. It turns out at these carrier frequencies, the attenuation is only 2 dB per kilometer, so very low attenuation. We can build extremely focused pencil beams with massive MIMO antenna arrays just on the package or on the back of in a 3D chip stack in silicon. So we can make this very cost-effective, low cost, even though millimeter wave sounds high cost. But I think there's a future to making these kind of systems very low cost. The other millimeter range that we're looking at is working on is the 60 and 70 gigs range, obviously. And then the third one is obviously the below 6 gigahertz range. The 28 gig obviously is a big thing in America.
Yeah, not so much for you.
I am still shying away from it a bit. I'm not a true believer that you can build low-cost terminals at this frequency, because the wavelength is too big to actually put this into a chip or into a package of a chipset, the whole antenna array, the antenna array. So you actually have to use the printed circuit board. So you have a distributed antenna over there, and it becomes costly and complex. And so it's too big, the wavelengths have integrated small, and it's too high, the carrier frequency, to have the advantages of the gigahertz, you know, the long range where we have nice penetration through walls and windows and whatever else. So somehow 28 gigs seems like You get the disadvantages of millimeter wave and the disadvantages of everything. So it's not so good. That's my way of looking at it.
All right, well, we'll have to keep an eye on it. Thank you very much. Gerhard Fettweis, Vodafone Chair at the University of Dresden, thank you so much for your time.
Thank you.